Welcome back with the next chapter, that is the structure of matter, chapter 3. Matter. All the objects around us, whether living or non-living, are matter. Water we drink, food we eat, air we breathe, chair we sit on, all are the examples of matter. That means matter is anything that has mass and takes up space. Matters appear in a huge variety of forms such as rocks, trees, computer, clouds, people, etc. Each pure kind of matter is called as substance. Here pure we mean the same throughout. Thus aluminium is one substance and water is another substance. Indian ancient sages found that the matter is not continuous, that does not exist in separate form. It is in fact made up of a tiny particles. The first person to suggest that all matters comprises of a very small particles was the great Indian sage Canada, and these particles were termed Anu by him. Then after that, John Dalton, a scientist of the 19th century, named these small particles atom in his theory named as Dalton's atomic theory. He said that the matter is made up of a small indivisible particles that we call as atom. So what are the compositions and the categories of matter? We know that matter is composed of a singular unit that we call as atoms, and these are the smallest particles of any substance. That means we can define that an atom is the smallest particles of an element that can take part in a chemical reaction. It may or may not exist independently. But even an atom consists of even smaller particles within itself. Here you can see the structure of an atom. It comprises of protons, neutrons and electrons. Protons, which are positively charged particles present in the nucleus of the atom, while that neutrons, they are neutrally charged particles that do not have any charge, hence they do not participate in any chemical reaction. And the last one, electrons, they are negatively charged particles that are present in the outer orbit of an atoms. Next, types of matter. Classification of matter, we say that earlier Indian and Greek philosophers and the scientists attempted to classify the matter in the form of 5 elements, that is air, earth, fire, sky and water. This classification was more of philosophical nature. In modern science, however, there are 2 main ways of classifying the matter, based on their physical state, and the second one is that based on the composition and the properties. Based on the physical state, that all matter, at least in principle, can exist in 3 states: solid, liquid and gases. And all of you know that what is the difference between the solid, liquid and gases, and what are their various properties also. And the second one, that is based on that composition and the property, that means it is be classified on their chemical composition. And the classification of matters includes elements, compounds and mixture. In broadly, we say that the matter will be classified into 2 forms, that is pure substance and the mixture. And this pure substance again be classified into element and compound, and the same has that mixture also be classified into 2, that is homogeneous mixture and that heterogeneous mixture. First one, that element. What is element? Element are a group of atoms which have the same number of protons in their atomic nuclei. Although an element's atom have the same number of protons, they can have the different numbers of neutrons and hence different masses. For example, carbon, tin, hydrogen and oxygen. There are about 118 different elements known to us. Out of these, 92 elements are natural, while the 26 are the man-made and are prepared by the scientists in laboratories. Then the second one is that compounds. When 2 or more elements chemically combine in a fixed ratio by mass, and the obtained product known as the compound, and the compound can be defined as the substance consisting of 2 or more different types of element in a fixed ratio of atoms. When the elements combine, some of the individual properties of the element is lost and the newly formed compounds has the new properties. For example, water. We know that it is composed of hydrogen and oxygen. Hydrogen and oxygen here will be the elements, and when these two elements combine, it will form a water, that is H2O. And the properties of hydrogen and oxygen as well as the water will be different. So, a molecule is the smallest particle of an element or a compound that can normally exist independently. And the third one is that mixture. What is mixture? When two or more substances mix with each other, it results in the formation of a mixture, and the substance or the solution that is obtained as a result does not lose the individual properties of the original substance, nor they are combined chemically. That means mixture as the only product of a mechanical blending or the mixing of a chemical substance such as elements and that compounds. That means you can say that I am giving some examples of also that the substance differ from that composition, means mixture are either be homogeneous or heterogeneous. Suppose you add 5 gram of sugar to water kept in a glass tumbler. After stirring, the mixture obtained is uniform throughout, and this mixture is called homogeneous throughout and is called solution. Air is a solution of several gases like oxygen, nitrogen, water vapors and carbon dioxide, etc. Suppose you mix sand with iron filling, sand grains and the iron fillings remain visible and separate. This type of mixture in which the composition is not uniform is called as heterogeneous mixture. If you add oil to water, it creates another heterogeneous mixture because the liquid thus obtained does not have a uniform compositions. System for determining symbols of the element. So the first question arises, what is chemical symbol? There are over 118 different elements which are made up of atoms, and the elements can be divided into metals and non-metal, and the chemical symbols and the formula are used to represent these elements and that compound. Each element is given its own chemical symbols like H for hydrogen or O for oxygen. Chemical symbols are usually 1 or 2 letters long. Every chemical symbol starts with that capital letter and with the second letter written in that lowercase. Here that system for that determining symbols for the element, here that various steps, just read one by one. First one, the symbols of the most common elements, mainly non-metals, use the first letter of their English name. Example, H for hydrogen, B for boron, C for carbon, N for nitrogen and O for oxygen. And the second one, if the name of the element has the same initial letter as the another elements, and then the symbols used for the first and the second of the English name. Example, helium, that is He, because we cannot give that H for helium because H is represent for that hydrogen only. Second one, lithium, Li, and beryllium, it will be Be. And the third point, if the first two letters of the element's names are the same as another element, then the symbol consists of first letter and the first consonant of that English name that they do not have in common. For example, magnesium has the symbol Mg, first letter and the first consonant. Manganese has the symbol Mn, chlorine has the symbol Cl, and that chromium has the symbol Cr. Then the fourth point, some symbols are based on that old name or Latin names of the element. There are 11 elements: natrium, Na, Sb, that is terbium, Kalium, K, wolfram, W, ferrum, Fe, aurum, Au, coprum, Cu, and hydrogen, that is Hg, argentium, Ag, and plumbum, that is Pb. Here some that based on their Latin names, but for example, kalium, that is a potassium, but in Latin name it will be called as that kalium, and the symbol is denoted by K. Next one, new elements are those with disrupted claims for the discovery and the synthesis are named using 3 letters based on the Latin for their atomic number. First letter U from uni or UN, that is 1. Second letter N from that nil, that is 0. Third letter from the Latin numerical prefix, that is Q for cured, that means 4. P for pen, that is 5. And B for hex, that is 6. S for sept, that is 7, or for that oct, which is 8, and E for enia, that is 9. Yeah, in your books there are several examples be there, and which will be shown in this slide also, that what is that English name of that element and what is that Latin name for that elements and their symbols. You just learn this all examples, which is important for your exam also.